morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, Transforming the Future of RAG with ColPali, brought to you by our friends at Vespa.ai. I'm Brian Mink, co-founder and president of Data Science Connect, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss how ColPali is revolutionizing multimodal information retrieval in Retrieval-Augmented Generation, or RAG, workflows. Traditional retrieval systems often miss key visual elements like images, tables, and layouts found in visually rich documents like PDFs. In this webinar, we'll introduce ColPali, a pioneering solution that seamlessly incorporates these elements, simplifying multimodal document processing and enhancing the accuracy of RAG workflows. We'll also see an exclusive live demo from the CEO of Vespa.ai and explore real-world applications at RavenPack, the leading provider of insights and technology for data-driven companies, including the most successful hedge funds, banks, and asset managers. We're honored to hear from two distinguished experts today, Jon Bratseth, CEO and founder of Vespa.ai, and Aakarsh Ramchandani, Chief Strategy Officer at RavenPack. Before we begin, a few housekeeping items. To make this feel a little more in person, we suggest you add a photo to your profile and include your bio, LinkedIn profile, and other information you want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the webinar. We'll be addressing your questions throughout, so be sure to upvote the questions you'd like our panelists to address. And finally, to learn more about how to leverage RAG in your AI journey, check out the call to action below throughout the webinar from our sponsor, Vespa.ai. Now, without further ado, I will welcome guys. Nice to have you, and we'll just kick things off with some quick intros. So if you wouldn't mind, each of you introducing yourself, tell us a little about what you do and what your organizations do as well. So why don't we start with you, Jon?
Yeah, hey guys, I'm Jon Bratseth. I'm the CEO of Vespa.ai. We're a startup and AI platform used by predominantly big companies that want to do RAG or other advanced retrieval and computations with AI over lots of data. Before I was the CEO of the company, I was the architect of the platform for the last 20 years. So I can speak to the technical details of it in detail that would bore you all, I guess.
Excellent. Welcome, Jon. Aakarsh.
Yeah. Hey, everybody. Aakarsh Ramchandani. I run strategy at RavenPack. RavenPack has been in the NLP and data analytics space in finance for over 20 years. Last year, we launched bigdata.com, which is a research assistant for financial professionals, and been working with Vespa. I guess we are one of those large startups that go to RAG at scale.
Awesome. Well, thanks for joining us, Aakarsh, and welcome to both of you guys again. We had a great webinar a few months ago on RAG, and there was a lot of interest in ColPali, so we're excited to dive into that in more detail today. So I want to just kick things off by asking you guys to give a quick overview of what is ColPali, what is Vespa, how are they related, how do they work together, and then we'll dive into a demo. So Jon, do you want to kick us off with that?
Yeah, I can do that. So the big new thing that happened so we need to go a few years back and take this in stages to make it make sense for people, right? So the big thing that has happened in information retrieval over the last 5 years is vector embeddings, right? It used to be the case that to retrieve something in lots of data, what you would do is you would index all the actual words of your data, and you would retrieve by reverse indices that looked at the words, right? That's still very useful. So not dissing that in any way. But the new thing that happened over the last 5 years is vector embeddings, right? Where we take the text and convert that into vectors representing parts of that text or the entire text, up to you, basically. That started as very simple systems like Word2Vec and so on, but then we got the large language models, which allowed us to create really great vector embeddings for text that really captures the meaning of the text on a meaningful level, right? So that allows us to, index data on the semantic level by indexing the vectors rather than the words. And if we do that, we can retrieve on the semantic level. We're also losing something. We're losing the preciseness that you get from retrieving with text, right? So the really best results you get is by doing both at the same time. Okay, that's the very basics. Then we got a new invention 2 years ago now, I think, that is called ColBERT, where we move from creating a vector embedding for a piece of text, like a paragraph or a page or whatever, to creating a vector embedding for every single word, right? So the new idea is you create vector embeddings for every word, but the words in context. So if you have the word it in a sentence, you will have a vector embedding for that actually represents the semantic meaning of it in that sentence, namely what it refers to in that sentence, right? And you do that for every word. And if you index all of those vectors, that's a lot of vectors, and you do the same thing with the queries, create a contextual vector for every word, and retrieve by that, you get really great results. The better results than using both text and these larger vector embeddings together. So ColBERT, that was a great invention a few years ago. And ColPali, which we're talking about today, builds on that and is a wordplay on that as well, right? What we're doing in ColPali, it's not our invention, but we have a platform that allows us to do it at scale. What we're doing in ColPali is a similar thing, but to images. So we take any image, typically pictures of pages in documents, right? And we cut them into small pieces, and then we create a vector embedding for each of the pieces of the image. And that's also contextual embedding, right? So if you have a number, for example, in the page or some bar chart or something, it will use the context around it to create a vector embedding that represents the semantics of that piece of the image in context, right? And to do this, you need visual language model, right? VLM, that is trained on multimodal data, both images and text, so it can understand both images and text. Because when you're retrieving, you want to create vector embeddings in the same vector space, but from the text that the user is typing, right? Okay, so when you put all this together, you chop the images into pieces, you create vector embeddings from those, and you then take the same visual language model and create vector embeddings for your textual queries that will be in the same vector space. And you retrieve by vector embeddings in this way, you get even better results that you can get with ColBERT. And the great thing is that not only are these results remarkably good if you're only dealing with text, but they actually see the figures and tables and graphs and so on in your documents, right? So they can retrieve and understand the visual information in your documents, which is very powerful and promising. I still say it's more promising than powerful. So we can see a demo. It's quite impressive, right? But if you want to deploy this at scale and have it to be reliable in every case and so on, there's still a lot of work to do with these models. But definitely something we'll see a lot more in the future, because not only does it allow you to understand the visuals in your documents, but it also greatly simplifies your systems, right? Because you can avoid all the textual extraction and all the things you have to deal with. Otherwise, just convert your PDFs or Word documents or whatever into images and chop them into pieces and embed them, and you're done. Maybe before we move on, now is a good time to show a little demo that gives you more of an intuition about how this actually works in practice. So we have a public demo out here. You can see the URL on top there. This is just hosted on with our nice friends at Hugging Face and available for everybody. So you can just Google, if you Google Vespa and ColPali, you will find it. So here we have an example query. It's a normal textual query, right? And in this case, we want to retrieve, in this demo, we have we can retrieve either by only these image patches, the vectors that you create from the image patches, or by simple textual retrieval, or combining both together. But here, now we're going to retrieve only by looking at these visual vectors. And here you can see we still find the right document page that actually contains the information about the number of graduate application, the trend of graduate application in these years, right? So it retrieves the right information without any textual indexing at all. So it only looks at this page. It doesn't there's no textual conversion or anything like that. And we can also here visualize what it's looking at these various pages to determine if this is a good match or not. If we click trend, for example, we can see that it's looking around on this graph among other places to try to figure out if there's a trend here. And if we click on one of the digits in 2023, we can see it focuses a lot on 2023 down here. So even though it's only visual, it has learned to look at text the same way as we humans do, more or less, right? And can understand that, first of all, 2023, the tree in 2023 is part of 2023, and then locate that on the page and focus its visual attention on that. Pretty similar to what humans are doing, right? And if you click graduate, you can see that it focuses on that there are something about graduates at this page. All this is just visual information. There's no textual retrieval or text processing at all here. And just to drive that point home, this is really a corpus of financial reporting data, but they have some nice illustrations, and we can similarly search for them. If we search for child jumping or puddle, we'll get this illustration down here. And we can see here that if you click on child, we can see that it focuses on the outline of the child here. While if you click on puddle, you can see that the model is looking deeply on the puddle to determine that it's a puddle. Right? So it's actually looking at the images and understanding them, and we are able to use that information to retrieve these pages among millions or billions of pages. Right? So that's the powerful new thing here. I think I'll stop there.
Yeah, great overview, Jon. So I guess just taking a step back from that, what do you find are the primary challenges in traditional document retrieval systems when it comes to handling visual data if you're not using something like ColPali?
Yeah, there's lots of problems, right?
Yeah, lots of problems. Yeah.
I think Aakarsh can speak to this as well. But I mean, especially if you're dealing with visual documents, right, that contains a mixture of text and visual information like pie charts and diagrams and whatnot, you're really losing a lot of information if you're only extracting the text as we usually do, right? Whether or not you embed that with vectors or do traditional retrieval or hybrid retrieval, it doesn't matter. You're losing a lot of information. I think that's the biggest problem, especially in domains like finance, as we saw now. A lot of the information that you want to consume is really in various charts and so on. It's also true in lots of medical documents, and even more so with some other clients you are working with in the construction business, right, where most of the information is really figures and charts showing where something should go and so on. There's just no way you can make sense of that without this ability to do visual retrieval.
Yeah, I can add to that, like from the domain of finance, at least, like bigdata.com today is a non-visual understanding platform. Even though we do visual understanding, but we do it, I think, the old school way, which is a pretty handcrafted set of rules that run through a OCR system, an extraction system. We are using vision language models to go extract details off the chart. And those are things that we were doing the traditional way. When ColPali came out, I think the magic for us, like we can talk about all the good things and bad things, but the magic for us is basically a pipeline that used to take 7 minutes long, and it used to take like 6 or 7 different steps with about, most of the work is on the long tail of when it didn't do it correctly. And you kind of replace that entire pipeline and saying, if your primary goal is to find the right piece of information within a rich document, you can now probably do that in like half a second or a second, and you can get that embedded really well. There's a lot of obviously infrastructure stuff that we can talk about there, but just that itself is like pretty much a game changer, especially for like domains which are rich in like multimodal information. And if you think about anything in finance, it generally is, here's my thesis, here's like 19 different charts that will walk you through why I think it's the right thing. And usually what happens is only the people that build the charts or know the charts know exactly where to look to go identify the piece of information that is relevant in the chart. So oftentimes you depend on the narrative around the chart to go read the chart. And like ColPali is kind of a game changer, and just like how should LLMs think about the same type of information in order to answer a bunch of questions.
Yeah, great points. And so how, I guess in terms of the workflows, how are you integrating visual data to enhance the performance of RAG workflow?
So on our side, I can tell you that we are not fully convinced that ColPali itself will solve all the problems. And you could take it as a controversial opinion or not. It completely depends on your domain. I think the demo that like Jon did is really good because it showcases that on a pure retrieval basis, ColPali is, even on the benchmarks I've seen, I'm just shocked at how good these retrievals are. These are non-fine-tuned models. You can imagine that if you were to fine tune ColQuen or something else in that, like perspective where you're like, this is a chart, here's an explanation of the chart as a user or a writer of the chart is actually saying it. If you can fine tune it on 100,000 examples there, you're going to get really, really good results for retrieval. Once you're done with retrieval, there's an entire set of reasoning which you have to do on top of it. And that's kind of where, at least our stance today is that we will definitely move to a system like this for the retrieval component. But I don't think OCR is going anywhere. I don't think parsing is going anywhere. I think those techniques are still here to last. It really depends. And we'll walk through, as we start talking, some applications of how we think a blend of these two pipelines is an incredibly new way to build assistance.
Yeah, Jon, anything to add there?
No, not really. But I totally agree that this doesn't solve all problems. And if you want to stay competitive and have the best solution, you need a mixture of lots of approaches to do something that is really good, right? I think that will always be the case. And then, of course, you need a platform where you can put it all together. So,
and a platform that just does it for you. You can just ask a question, right?
That is true.
Absolutely. Yeah. We do have a question in the chat here. In ColPali, how do you handle errors when creating vector embedding for images that differ in handwriting or font style? Like, for example, 1 and 7 could look like the same.
Yeah, it's a good question. So at least in the systems we have been experimenting with so far, we are a platform provider, right? So maybe Aakarsh has a more practical answer. We have seen this. It's not perfect, right? It's making mistakes in 100 different ways, and this is one of the ways. And this, as we're using larger models that are more capable and handle more modalities and so on, they will actually make mistakes that are more human-like, right? So this is just like when we are reading somebody's handwriting, we can mistake a 1 for a 7 and pay people 7 times as much as we should, or whatever, right? And the models definitely do these kind of mistakes as well. And the problem, right, is that there's no way to detect it while you're embedding and indexing the data. You just don't know, right? The only way I can think of knowing is to use different models at the same time and then somehow compare the output, but we don't really know how to compare the output. So we haven't really gone anywhere with that idea.
Well, Aakarsh, I want to jump into some specific use cases that you guys are actually deploying at RavenPack. Would you mind sharing some of those? What are some multimodal use cases that you guys have worked on?
Yeah, I think the number one request, if you're working in finance, you will quickly realize that news is one part of the equation, and earnings transfer. Like, we get information in multiple modalities. We get sound, we get like websites, so where people are talking about it. We get PDFs where people are actually describing a analysis, a report. Like, that's kind of the business of like finance. And then multimodality is especially relevant when a company is like telling the world about its strategy. So they issue presentations that are almost like purpose built for a multimodal system like this, because it quite literally looks like a beautiful graph. There's a tiny image somewhere inside it. There's a human being, like right next to it, and then 5 stats. Now, we've experimented enough with OCR. I can tell you that OCR will say, I think this is a piece of text. I think this piece of text belongs to this chunk that we've created, but there's absolutely zero visual clues about how that information is kind of represented. So the biggest use case today is most retrieval systems kind of have to move into a multimodal paradigm. And this is not just input, by the way, it's input and output. Because there's an expectation that if I am asking you a question for a table, you should reason over a table, but then present the answer back to me as a table or across 3 different tables that you have to go collect information from and stitch it together. And that's what I meant by saying, if you look at the entire pipeline of you are trying to build a assistant in your domain, or you're trying to build a RAG tool that is really Q&A based on a series of things that you're building, that's kind of where the multimodality is extremely useful. There's pieces of information that exist in just text. There's a lot of information that exists in PDFs. There's information that you want to commingle between the two. Those are some of the most obvious use cases. You can ask a question about what is NVIDIA's plan for semiconductor data centers as an example, right? The answer here is that there's a podcast where Jensen is talking about what their strategy is. So we're running, speech to text, models to convert that, and then we analyze it. There's a news article that is written about the exact same thing from Reuters, and we will scrape that on some kind of website, and we'll say, hey, we found this link to this website. You should actually go and read it. And then most importantly, there'll be a presentation that NVIDIA will put out, and it's a hyper technical presentation. In slide 19, they will lay out their semiconductor partners and their strategy inside it. That just being able to run 3 different searches in 3 different modalities, synthesize the information and present an answer, that's kind of the biggest use case for what we're building in big data.
Yeah, those are great examples, Aakarsh. Jon, what use cases are you seeing?
Yeah, so finance use cases like this, for sure. The other ones I mentioned briefly in medical systems, healthcare, so on. That's another big promising user of this, and they have similar needs, right? And the more you get towards research in these spaces, the more you have, you're looking at various different papers that have these different scatter plots and whatnot, and you're trying to synthesize information out of that, seeing if it compares across these different papers you're looking at and so on. So I think you have similar challenges in that space for sure. And then even more so in, as I mentioned, in the space that are inherently visual, right? Like architecture, construction, and so on, where most of the information that people want to communicate and find and so on is both precise and completely almost graphical, right? Which is a somewhat strange combination where I think these models and retrieval ways of retrieval also matters a lot. There, I think we also need. So I talked about how we do this patching, right? You're just splitting the image into patches. We are doing a little trick in addition, which is providing a small text with each of the patches that says, what's the context of this patch? In some of these systems, and I think this is particularly pertinent in construction and architecture and so on, these patches on their own are kind of often very similar because it's stylized information, right? So you have an edge and a line or whatever, right? It's still contextual, right? But there's limits to this contextual information. So what we are interested in is doing more of this thing similar to combining patches and texts, but also combining visual information at different zoom levels in the same vector embedding, so that you have high-level textual description of what is this? Is this a drawing of a house or what, right? And also you have a low-resolution image that says, this is the thing you're dealing with, and then this is the area you're dealing with, and then the detail patch, finally, that shows you exactly the details about what you're looking at now. And then embedding that entire thing as a single vector embedding. We believe that can be very powerful in some of these applications. So there are some experiments around that. I think we're far from seeing the limits of what we can do with this way of thinking, with the simple thing we're doing here with these single level patches and a short textual description. So there's a lot more to do in this space for sure.
Jon, I'm out of just curiosity. Are you fine-tuning vision models that are good at the contextual? Here's a piece of text, here's the line or chart exactly that represents the text, and that way on the retrieval side, it kind of knows that like, this is a joint representation of this exact type of query and this type of visual. Like, is that the approach that you've seen some like value in?
Yes. So to be clear,
Okay.
this is people we're working on doing to be doing the actual fine tuning. We are not providing those models to third parties.
Yes.
Yeah, but you need to fine tune the models. Yeah, because the information gets more complicated, right? So the model needs to be fine tuned to make sense of it.
Have you seen the same? I'm sorry, Brian. I know there are like
By all
there's
means,
some more
keep
questions here, but
keep going.
like we have this open-ended research question right now, which is how many patches is enough for a page? So let me just start there because it has a lot of implications itself.
Yeah, you want the general answer that is true.
Yeah, I just want to know from your perspective, from your like vantage point, how are you thinking about this in real world problems, or how are your clients thinking about it as well?
Yeah, as always with these questions, there's no universal answer, right? It depends on the information density in these images. You can imagine with this, if you have a construction chart for building something, for example, there's lots of detailed information in the image, right? So you need lots of patches. While I think, I haven't tried, but I think in your example with earnings reports, presentations, or stuff like that, it will be pretty simple. So I think you can get away with a lot fewer patches. One interesting thing that maybe some of you noticed when we showed that demo is that there's some amount of white space in all of these figures, right? But sometimes we can see that the model attends a lot to this white space. We don't know, but we believe that the model is using the free space to add additional thoughts it's having about the image.
Okay.
So maybe that's a sign that you're going too far if you're seeing a lot of that.
We do have a question in the chat, and this is relevant to any conversation about AI regarding just accuracy. So Pradhan says AI has to be perfect, especially in the medical field where it is life or death. You can't make mistakes in dosages. So, what would be your guidance when using ColPali around that? How do you address concerns of accuracy?
Yeah, so the applications that we have seen so far, visual retrieval is more towards, not necessarily completely towards, but more towards research than this applied day-to-day kind of thing, right? So luckily with visual retrievals, we haven't so far encountered this particular problem. So we have it with some usages with Colbert and so on, where it's actually kind of impressive to me that the healthcare space has gone so far in using these new AI techniques, because they actually have applications where you get advice on what to do from chatbot and so on that they actually put live. And there you have pretty stringent requirements around this. Right? I don't think the visual models are mature enough for these kind of applications so far. And in research, it's not that big of a deal, right? Because the guy who's consuming it has a PhD and can detect hopefully when the model is doing something wrong.
I think that applies to finance as well. You may not die, but you may lose your job if you make a bad recommendation of it. So I think at least for us, it's more trust but verify, right? It's one completely different thing to present information to a user that we believe is smart enough to make a judgment call based off information we've retrieved. It's something completely different to give an agent the ability to make a recommendation or execute a trade. In our case, would be to execute a trade on that behalf. I don't think these technologies are to a point of comfort. I'm not saying maturity, I'm saying comfort, where that we would be comfortable with it running fully autonomously. So the approach we're taking today is present the right information with the right context in the right timeline that we receive it to our users, and then ask the user with all of the source attribution, or in this case, it could be the exact piece of a PDF that we saw. This is the information we think we found. Is this what is relevant to your query or not? And oftentimes it leads to a follow-up, a validation, and then oftentimes show me the table where you actually got it, right? So that's kind of where I keep saying, like, at that point is when you have to start thinking about all the other systems you need to build in order to make sure that the experience is close to helpful as possible.
Yeah, I think you're touching upon a very important general point as well, that we have an advantage with this kind of retrieval-backed systems that the two of us are building, right? Where the model isn't just coming up with something that may be from reality or maybe something it just made up, right? The information is actually retrieved and then synthesized through a model, but you can still look at the source to verify, right?
Yep.
Yeah, great points. And in line with that, where do you see things going in the next few years? I mean, how do you think we get to a point where maybe we can open up new use cases because there's a certain level of reliability around this, or at least a certain level of comfort, to your point, Aakarsh? What are your kind of future predictions about the world of multimodal in the next few years?
I can do a general answer, which is we just need better visual language models. They just need to be smarter, right? So it was the same thing with language models early on, right? So they were making up a lot of stuff, making a lot of mistakes and so on. They can still do that, right? But because they are a lot smarter, they know that in this context, I shouldn't make something up. In other contexts, it's completely fine to make something up, right? You don't want a model that can't make stuff up because it can't write a short story for you or whatever you want, right? But if it's smart enough, it knows the context and it understands in this context, it's very important to be factual and not do that, and to be careful to say, I'm not sure, all of those things, right? And the textual models are at that level now that they can actually do this, right? The visual models generally are not yet, but I think we'll get there.
Yeah, I actually fully agree this time around. It's kind of fascinating. Like, what is it? 2 months ago was when like Gemini 2.0 launched. That's the first kind of purely multimodal model that I've seen that kind of blew my mind, which is like, okay, we've finally started to reach a point where these, like, especially the training data sets, which are predominantly like computer use ones, I would say, where it's actually getting, very, very good because there's enough data that it's been trained on what a page looks like, what is a button, what is an accordion, what do I click on, etc., like that, where we're starting to see massive improvements in a model itself being able to use the visual information. So if you were to ask me, I would say I hope the retrieval models get smaller, because right now, nobody talks about the 3 billion like parameter model. If I'm going to index it, what capacity can I run it at? How much do I need? What kind of concurrency can I do? There's a ton of questions there that actually occur at scale, especially with these larger models. But if you can retrieve something, and I can present now not just text, because that's kind of what we are today limited to. We retrieve, information from a lot of different places. We have to convert that information into text form and then have a much smarter model reason about the text that it just retrieved. That paradigm might change, or it probably is going to change. Give it 1 or 2 years, and it's going to be completely different. That we don't just have to retrieve text anymore or convert whatever we've retrieved into text to go feed it into a reasoning model. We can literally just say, I'm finding this information. This is represented in bits. This is an audio podcast. This is a text thing. This is a picture. This is a PDF. And here's like 3 tables or like pictures of tables that we got in. Please now go reason over this information. That to me is kind of where I see, within the next 2 years, we'll probably head in that direction, and these models truly will become capable of doing that kind of multimodal reasoning.
Yeah, excellent points. So for folks looking to get started on this today, where would you begin? What if you're just starting out with ColPali and you're trying to figure out, what are its capabilities? How would you get started on this?
Well, it's easy. You can just click on the learn more here, and you will get a result you can follow, and you will have your own application doing this up and running.
And
We also, by the way, has a result you can use to scale this to billions without spending way too much money by using smaller vectors. So if you have some experience with this, you know that vectors are expensive, right? And in this case, you will end up with a gigantic amount of vectors, right? What you can do then is to convert those vectors into binary vectors where every number is just represented by a 0 or 1 with a threshold that usually is just 0. You can do that. You can also shorten the vectors, and you can still get almost as good results. It's pretty amazing, actually. And that saves you both lots and lots of memory, and also saves you a lot of CPU, because you can use Hamming distance calculations to compute the vector distances rather than more expensive floating point calculations. So if you want to try it, click on the button or Google Vespa and ColPali, and you can have your own application up and running. And if you want to scale it to billions, you can find a result for doing that as well. It's not a big change, really.
That's great. And I guess what lessons learned you guys have as you do start to scale this, right? What are some considerations that you might have at scale that you don't have if you're just doing this in a POC context?
Aakarsh, talk about scaling woes.
Yeah, scaling laws. I mean, there are a few things that I would at least think about if you're going to implement a pipeline like this. One, and the starting point here is, do vision models work well with your type of domain? So your domain's context. And that's a pretty important thing to start with before you decide to go all in on a ColPali style approach, because I've seen a lot of new models come out, ColQuen and every variant of it, ColSmall, ColQuen, ColSmall3, so on and so forth. There's all of these ones that are coming out. And I think if you're about to start and you think vision transformers would be good in your data set, start with just 10 PDFs or 20 PDFs. Find ways of hiding information, or find pieces of that PDF that you think are really relevant to your domain, and at least start testing how good is it in retrieving the right piece of information. Is the attention going in the right place? I think, one of the challenges with models like this is, how do you know it's retrieving the right information in the right place? Because it's all visual right now. It's not that I get a expected text input, and then I compute, okay, is this the correct one? And I use a large language model to verify it. I think those things are still interesting problems, because the way you could solve that is basically then you get a vision model to reason over the thing that it just retrieved. So it can start getting pretty complicated there, but I think having that baseline is important, because you need to make a choice how much fine tuning do you need or not. Then immediately after that, I think the biggest issue for us and anybody else is what kind of compute do you need to generate the embedding, right? As I said, great, you have a 3 billion parameter model. I can, produce extremely good embeddings, based on that. I can binarize them, absolutely, but you're talking about a very intense index operation. It may take, half a second, but that's half a second for a single doc. Do you get 20 docs at a time? Do you get 100 docs at a time? How much compute do you actually need to run that? Do you have any latency requirements? Those lines, you really need to ask yourself, what is the type of data set you have? What is the frequency of new PDFs or images or stuff that you get? And then what is the size of that archive? Because a lot of this stuff, if it's small, I don't think you need it. You could just use the larger language models today as an API and get away with a lot. There's this whole context, long context versus RAG. And I don't want to get into that debate here, but it's just that depends on the size of what the application is. We're seeing, the newer models with rope embeddings and stuff, it's starting to get pretty good at long context. So even for us, it's surprising to see how quickly the space is moving.
Yeah, absolutely. Anything to add there, Jon, about scaling this?
No, what Aakarsh is saying is all good points, and I think it boils down to you need to know why you're doing this, right? And really knowing why operationally is to have an evaluation so that you can actually score yourself on how well you're doing on what you're trying to do, right? And as you were alluding to, that's a bit harder with these visual models because usually you can just deal with text, and language models with text is trivial, and you can generate evaluations pretty easily these days, right? You can sort of follow the same idea with these visual models, but it's not as straightforward yet. It will get there, but it's fun to try things out, and by all means do that. But if you want to seriously do this and scale it, then start with figuring out evaluations and go from there.
We got a question in the chat from Jorge. What about VDOR? And I'm sorry if I mispronounced that, but it's the VDOR benchmark associated with ColPali. Can you guys explain a bit more about that? You're probably more familiar than I am.
Yeah, it's one of these visual benchmarks, right? There's a number of those. I don't know what more to say, but yeah. If in the context of having evaluations, right? Yeah. Well, you can test the models. How good is the model using these standardized benchmarks, right? But in the end, you don't really care how well it does on a benchmark. You care how well it does on your data for your problem, right? And that can be very different. We have seen that like forever in textual retrieval as well, right?
Yep.
So you actually need to create something similar with your data for your particular problem. That's the only way to know that what you're doing actually makes sense and is cost effective for the money you're spending on it and so on.
Got another question in the chat here. What about creating accessibility information for charts and images for online content versus having to do this manually? Is that a use case you guys have seen, the accessibility component of analyzing visuals and then presumably translating this to text?
No.
Is the accessibility information as in like, hey, can you describe this chart for me? Because
right, I'm assuming like for ADA, for the blind, for instance, converting images to text.
I think a lot of these data sets are created that way. They're actually created by using vision transformers to then say, please describe it, and then having it from 3 different perspectives. When you have a really good description, you give it to a human labeler to just validate it. That becomes your golden set. Now you have like a starting point. Now it's about going and creating a much larger synthetic data set to either fine tune your model or test your model. So I think accessibility information is providing context for a piece of chart. I think vision transformers today, especially whatever's coming out of the cracked team at Alibaba, is really good. So clearly they have access to more data than we do because they're creating some pretty good models here.
Yeah, I think it's not particularly relevant in this to this, right? But in general, visual text models should be great for accessibility, right? Because they are able to just take some visual input and convert it to text. So if you're almost blind or whatever, you can have there are already applications like it, right? That reads out what they see on the screen or a window and so on, and that is using this kind of technology. That is kind of the foundation for what we're doing here, but this is like a different application to me.
Well, we're just about to the end of our time, guys, but I wanted to wrap up with our lightning round and have you kind of leave the audience with your one key takeaway from today on the future of RAG with ColPali or multimodal. So why don't we start with you, Jon? What's your takeaway for the audience in one phrase or a couple?
I'll try to be fair and balanced and say, if you're working with documents with some kind of visual information, it's time to start thinking about visual models and have you incorporate it and leverage in what you're doing. I'm not saying you should throw away everything you have and just run towards these kind of solutions, but start thinking about how you would apply them, because we are definitely going to go there, that this will be a standard and integrated part of what people are doing with document retrieval.
Absolutely. Aakarsh?
My thing would be first see if a simpler version of it works before you complicate your life. Because truly is with all of these newer like techniques, please look at the costs involved in it, because they scale up in ways that will always shock you. So the size of the model, the size of the archive, what kind of compute clusters you need, how many users you have, those are things where starting from that baseline will really guide you towards a much more, because ultimately you want to do something fast to prove it out. Once you've proven it out, then you want to go tackle these 1 or 2 problems really well, and it'll give you much more bang for buck, and it'll give you a much better direction of where you can head.
Yeah, excellent points and a great discussion, guys. It's a pleasure having you again. So for our audience, if you missed any of today's webinar or you want to rewatch anything, the recording will be available just a few minutes after the webinar. If you just refresh this page, we'll also send the recording out via email tomorrow, and it'll also be on our YouTube channel. I want to say a thank you again to our speakers today, Jon and Aakarsh, as well as our partners at Vespa.ai for making this webinar possible. And we'll see you all again next time. Thanks.
Thanks,
Thanks, guys.
Guys.